Milling, or cold planing, removes some or all of the non-granular layers of existing pavement to provide the desired surface elevation and texture for asphalt overlays. Milling is categorized as full depth or partial depth. Full depth milling removes the entire asphalt layer down to the base and is used for pavements with significant structural issues like alligator cracking or rutting. Partial depth milling removes only the upper portion of a distressed asphalt layer, leaving the remaining layers as structural support after rehabilitation. Power-operated milling machines can remove pavement in widths from 6 inches to 13 feet and depths ranging from a light scratch mill to approximately 1 foot. Choosing the correct milling depth is crucial for quality, productivity, and project cost. The designer specifies the total milling depth required to remove pavement distresses and achieve proper grades. The contractor then determines the number and depth of milling passes based on factors such as machine size, total milling depth, material hardness, and the desired final grade and surface smoothness. If the depth of cracking is unknown, the designer should core along the cracks to assess their extent and determine the appropriate depth for partial milling. For instance, if cores show cracks ranging from 1.7 inches to 2.2 inches deep, the designer may set a milling depth of 2.5 inches to remove all deteriorated pavement. Other milling techniques include profile milling and variable depth milling. In profile milling, the surface is milled to follow a predetermined contour. For example, runways often require a crown profile to facilitate proper drainage. This technique ensures the surface is milled to the desired slope and curvature, effectively managing water runoff. Variable depth milling addresses varying levels of wear by milling deeper in areas with significant damage and shallower milling where pavement is in better condition. Incorrect milling depth can cause issues like scabbing, where a thin layer of pavement peels off, delamination, where the layer debonds but remains in place, or disintegration, where the surface disintegrates into small pieces. Scabbing can lead to variations in surface texture and elevation, weakening the bond between layers and causing issues like cracking, delamination, and density problems. This can result in a rough ride for planes and premature pavement distress. If scabbing occurs during milling, the contractor should lower the milling head and make another pass to fully remove it. Slowing the forward speed can also help prevent scabbing. Milled pavement surfaces are dusty and dirty, which can weaken the bond with the new asphalt overlay and create a foreign object debris hazard for aircraft. The FAA requires daily sweeping of milled surfaces, especially immediately after milling and before paving, to remove all residue. The texture of the milled surface also affects paving operations. The grooves left by the milling machine increase surface area, which typically requires more tack coat than an unmilled surface. Tack application rates may need to be at the upper end of the recommended range provided in the guidebook or specifications.